Test mic. Okay. So good day everyone. This is again Engineer Freedom Karodan, and for today's video, I'm going to compute for our example 2 regarding prop beams. So as you can see sa screen, considering the non-prismatic prop beam loaded as shown, so makikita nyo na magkaiba na ang flexural rigidity within our span of the beam. Meron tayong 2EI and meron tayong 1EI sa segment BC. Okay, so again, let's perform the structural analysis in our example. So yung tanong dyan is shear and the maximum moment. So ayan, gagawa ulit tayo ng structural analysis of our beam. So before we do that, sketch ko muna siya sa aking notepad. Okay? And then, so yan na yung ating beam. And so in this video, I'm going to use siguro area moment na lang para maiksi lang yung ating video. Okay? So if you try to use the other methods naman, you will arrive with the same answer. So try nyo na lang siguro sa inyong mga bahay. So dito sa video na to, I will just use moment area method. Okay? So again, since hindi natin masolve yan using the equilibrium equations na ma-determine natin agad yung reactions, let's use the deflection method, particularly area moment method, in determining our reactions and our shear and maximum moment. Okay? So first is to find our reaction in terms of one variable or one reaction. So hahanapin ko yung reaction using the equilibrium equations in terms of RB. So let's do that. First, we have the reaction at A in terms of RB. We can use the equilibrium equation, which is the summation forces vertical is equal to 0, and then we have upwards na RA and upwards na RB, and then downwards na 65 na concentrated load, downwards na uniformly distributed na load. 35 times 6 should be equal to 0. Therefore, RA in terms of RB is equal to 65 minus 35 minus 6. So check nyo na lang yung mga computations sa aking video. Okay? Pero I assure you na tama yung mga yan. And then for the moment at A, I can use the summation moment at point A. Clockwise is equal to counterclockwise. We have this first, itong concentrated load na clockwise, 65 times 2, moment arm niya na 2. And then our uniformly distributed load, 35 times 6. And then from point A, we have 2 plus half of 6. Okay. And then our counterclockwise na moments, MA and ito, counterclockwise na RB. RB times moment arm niya na 5. Okay, so solving MA in terms of RB, makukuha niya itong sagot na to. So kindly check na lang sa inyong mga respective na places. Okay? So this is our reactions in terms of RB. So next naman na gagawin natin is to use our area moment method in solving our reactions. So sa area moment method, anong unang ginagawa natin? Tama. We create a moment diagram using the moment diagram by parts. Okay? Now, gagawa ako ng moment in terms of the moment center sa ating RB. Okay, so nandito yung, let's imagine that this is our fix na support sa reaction at B. Okay. Okay, so yan. So first is our RA or RB. Hindi ko napalitan, wait lang. this should be, since in terms of RB na tayo, this should be 275 minus RB, and then 1180 minus 5RB. Okay, so yan. You can start. So we have the reaction at A, which is 275 times RB. Triangular lang yan, 1 degree. Okay, and then ang magnitude niya dito is 275 minus RB times 2. Okay, 275 minus RB, times 5. Okay, and then i-modify ko na yung aking mga magnitude since this is 2EI. So since 2EI yung ating fractional rigidity, so di-divide ko na siya in terms of divide ko siya in divided by 2 since 2EI yan ang ating flexural rigidity. And then we have this moment at point A. So since counterclockwise yan, magiging negative. Ayan. So this magnitude is negative 1180 minus 5RB. Okay. And then we have, since nandito pa rin siya sa segment na AB, therefore, i-divide ulit natin siya sa kanyang flexural rigidity na 2. Tama ba? Okay. And then, next naman is this concentrated load na 65 here. So, triangular lang ulit yan. So, yung point na to, papunta dito. Okay. So, 6 times 3, that is negative 195. And then, nasa segment pa rin siya ng AB. So, i-adjust ko na lang siya by dividing it by 2. And then, we have drawing ko lang. We have this uniform distributed load, which is 35. So, nandito siya. Since 0 degree yan, therefore, yung moment na is a 2 degree curve. So, alam naman natin yung formula dyan, which is equal to negative W L squared over 2. Therefore, our moment here sa baba in our second degree na spandrel is equal to negative 157.5. And again, we have to adjust the moment since our flexural rigidity is equal to 2. Okay. Next, we have this part here. Ito. Our uniformly distributed dyan in terms of the fixicity at B or the moment center at B. Therefore, siya ay isang second degree spandrel. So, drawing ko siya here. Okay. So, ganun ulit. WL squared over 2. Therefore, our moment here is this is 157.5. So, yung adjustment na gagawin natin is wala na since i-divide lang natin siya sa 1. Okay? So, this is our moment in our beam with respect to the moment center in point B. Okay? Ayan. And then, kapag dinrawing natin yung deformation nitong beam na to, it should look like this. Okay? So, wait lang. So, exaggeration na lang yan, class. Ha? So, our deformation should look like this. And then again, for the analysis of slope naman, the slope of A is horizontal. Therefore, so, drawing ko na lang ulit. Since our slope at A is horizontal again, and our point B is a support, therefore, our analysis is that the deviation of B with respect to A is always equal to 0. So, ulitin ko. Ang slope natin sa A is horizontal and our B is a support. Therefore, our analysis for this is that the deviation of B with respect to A is equal to 0 since, again, ang B rin natin has a deformation of 0. And then now, sulat ko na yun, that the deviation of B with respect to A should be equal to 0. Okay? So, since our deviation is just equal to the area that is considered times the centroid with the point of consideration. Okay? So, yan. 0 is equal to, so area, ang consideration natin is area AB. Therefore, the triangle is 1/2 times 5 and then ano ba to? We have 275 minus RB all over 2 times 5. Okay? And then yung kanyang centroid is just the 1/3 of 5 meters. Okay? So, yan yung ating triangular dyan na moment. And then we have this ano ba? Concentrated moment here. Ito. Due to the moment at A, we have ang base niya is 5 and then our height is 1180 minus 5RB all over 2 and then ang moment arm niya is just the half of 5 meters. Next is this triangular load sa baba. You have 1 minus 1/2 times 3 ang kanyang base and then kalahati ng negative 195 is 97.5. Okay? And then we have its centroid with respect to B that is that is 1/3 of 3. And then this second degree spandrel, 1/3 base times height. So, ang base niya is 3. And then we have our height which is kalahati ng 157.5. That is 78.75. And then, kanyang moment arm, that is 1/4 of our length ng kanyang spandrel. Okay? 3. And then, okay, yan na. Therefore, kapag sinif-solve nyo yan, siguro kaya ba yan ng calcu? I think hindi. So, isi-simplify ko na lang siguro. Okay? So, lalagay ko, wait lang. And so, kapag sinimplify nyo yan, now, yung ating term here is, pwede nating salpak sa calculator. So, isa lang naman na dyan yung variable. Therefore, we can solve for our reaction at B, which is equal to 226.355 kilonewton. Okay? And then also we have, since meron na yan, therefore, paano? We can solve for the other remaining na reaction since in terms of RB tayo. So, RA is just 275 minus RB which is 226.355. Therefore, our reaction at A is equal to 48.645 kilonewton. Okay? So, solving naman for the moment at A, we have 1180 minus 5 times RB which is 226.355. We will arrive with this answer. 48.225 kilonewton meter. So, paki-double check na lang sa mga pwesto nyo kung tama nga ba yung sagot ko, and then if meron tayong corrections, then you can PM me for the corrections, okay? Ayan. And then we have to proceed na tayo in the structural analysis to compute for our maximum shear and maximum moment. So, drawing ko lang muna ulit tong beam na yan, okay? So, wait lang. Ayan. Now, we are ready to create our shear and moment diagram. So, first, I will find for our maximum na shear. So, ito yung ating shear diagram, okay? First, we have an upward force na upward reaction na 48.75, therefore tataas yan ng 48.645. And then, since wala namang load na kakontra dyan, so hanggang dito siya. And then, next, we have this downward force na 65, therefore 65 minus 48.645, therefore ang shear here is equal to 16.355. Okay? So, check nyo na lang kung tama nga ba. Negative 16.355. And then, since we have this uniformly distributed load, ma-minus natin siya since downward force. So, 35 times 35 times 3, negative 35 times 3 minus 16.355, therefore, our shear here is equal to negative 121.355. Okay? And then we have this upward force here na 226.355. Therefore, negative 121.355 plus 226.355. Therefore, equal siya sa 105 kilonewtons. And then we have this downward force na 35. So, 35 times 3 is just 105. And then, now, magsasara yung ating shear diagram. Okay? So, this is our shear diagram. So, just by looking, ang maximum shear natin should be equal to this here. Pinakamataas sa kanila, which is 121.355 kilonewton. Okay? Very basic, di ba? Very basic. And then, solving naman for the maximum moment, of course, gagawa ako ng moment diagram. Okay? So, sa moment diagram, first is meron tayong counterclockwise dyan na 48.225. Since counterclockwise yan, bababa yung ating moment here. 48.225 kilonewton meter. And then, we have this rectangular na shear diagram. So, yung area ng shear diagram, yun yung ating moment. So, negative 48.225 plus 48.645 times 2, that is equal to... Wait lang. So, dito lang dapat siya. 49.065. So, yan dapat siya. Since 0 degree curve, 0 degree, and therefore this is 1 degree. And then, next, since yung load natin dito sa shear diagram or yung area dyan is for trapezoidal, therefore, the moment here plus the area of this trapezoid. So, 49.065 minus 16.355 plus 121.355 over 2 times the base, which is, sakto dapat to. Okay? Mali na yun. So, dapat yan is 3 meters pa rin yan. So, we have 49.065. This should be. The answer here is 157.5. And then 157.5 plus this area here, which is 105 times 3. So, makukuha, so 105 times, 1/2 times 105 times 3, that is 157.5 rin. Therefore, magsasarado yung ating moment diagram. So, this is a 2 degree curve, this is 2 degree curve. Okay? So, just by looking sa ang pag-analyze natin, ang ating maximum positive moment is equal to diba? So, siya lang meron dyan. So, 49.065 kilonewton meter. Tama ba? So, check nyo lang sa inyong mga seats kung tama ba. And then, for our maximum negative moment, that is equal to, ito, 157.5 kilonewton meter. Okay? And kung tinanong naman is our maximum moment lang, therefore, yung mas malaki sa kanila, that is 157.5 kilonewton meter. So this is our answer in the structural analysis of our example number 2. So bakit hindi natin gagamitin yung shortcut formula? So since makikita nyo naman na dyan that the loadings are medyo complicated, therefore we cannot use the formula that is provided in our example 1. Therefore, mas maganda pa rin, again, naulitin ko that to follow this kind of analysis, okay? So, yun lang for this lecture video. I hope you learned something in analyzing prop beams. Okay, so next is for restrained beams, maybe, and then I will discuss the fixed ended and then three-moment equation. So, abangan nyo yung mga lecture videos na yan. And so, yun lang. Thank you for watching and adios.